a segment AB and point M is midpoint of segment AB. I draw a line L which is perpendicular to segment AB at point M. So this line L is the perpendicular bisector of segment AB. Take any point P on this line L and compare this AP and BP by using divisor. Then we observe that this PA equal to PB means every point on a perpendicular bisector of a segment is equidistant from end point of segment. Then take another 2 points, point C and point D, such that these 2 points are equidistant from A and B. Then observe that these 2 points lies on the line L. Means every point which are equidistant from end point of segment are lies on perpendicular bisector. These two properties are the 2 parts of perpendicular bisector theorem. So let us see what is the perpendicular bisector theorem. Perpendicular bisector theorem. So first we prove the first part of that theorem. Part first. Every point on perpendicular bisector of segment is equidistant from the end point of the segment. Here I draw a figure, segment AB, and given line L is the perpendicular bisector of segment AB at point M. So in the given part, here I write line L is the perpendicular bisector of segment AB at point M. And take another point P is any point on that line L. And we have to prove that this point P is equidistant from the end point of segment. So we have to prove that this PA equal to PB. These two segments are equal. There is a construction drawn. I draw a figure also, that is draw segment AP and segment BP. So what is the proof of that theorem? To prove this theorem, we use the test of congruence of triangles. Observe the figure. If we prove that these two triangles are congruent, then we prove that this PA equal to PB. Let us start to prove this theorem. Proof. Observe, in triangle PMA and triangle PMB, this segment PA congruent to segment PM congruent to segment PM. Reason, common side. This angle PMA congruent to angle PMB. Reason, each 90 degree. Angle PMA congruent to angle PMB, each 90 degree. Segment AM congruent to segment BM. Here given this line here is perpendicular bisector of segment AB at point M, means M is the midpoint of segment AB. So this is given part. So here is an given, and therefore these two triangles are congruent by SA S test. So triangle PMA congruent triangle PMB by SAS Test. Triangles are congruent, so corresponding sides are also congruent. So this segment PA congruent to segment PB. Reason, corresponding sides of congruent triangle means CSCT, and therefore this length of PA written as length of PA equal to length of PB, means PA equal to PB. So hence every point on the perpendicular bisector of segment is equidistant from end point of the segment. Second part of perpendicular bisector theorem is any point equidistant from end point of a segment lies on perpendicular bisector of a segment. Here I draw a figure. Segment AB is drawn and any point which are equidistant from end point of a segment. Here point P is taken which are equidistant from this point A and B. Then this point P lies on the perpendicular bisector of segment, means P lies on the perpendicular bisector of segment AB. So given part of that theorem, point P is any point equidistant from end point of segment AB, that is PA equal to PB. And we have to prove that this point P lies on perpendicular bisector of segment AB. There is a construction is that I shown this construction in the figure. That construction, take midpoint M of segment AB and draw line PM. Here M is the midpoint of AB and line PM is drawn. Here we solve this, prove this theorem as activity based question. So let us start proof. In triangle PMA and triangle PMB, segment PA congruent to segment PB, PA congruent to PB. So here reason is dash dash. This PA equal to PB, this is given. So right here reason given. Then this segment AM congruent to segment BM, AM congruent to BM. So here take midpoint of M of segment AB. This is the construction. So here reason is the construction. Here take segment PM congruent to dash dash. Common side. Common side means this segment PM equal to segment PM. And therefore this triangle PMA congruent to triangle PMB dash dash. So here 1, 2, 3. 3 sides of one triangle are congruent to corresponding 3 sides of another triangle. Therefore these two triangles are congruent by yes. Test. Angle PMA congruent angle PMB. Reason, corresponding angles of congruent triangle. But angle PMA plus dash dash equal to 180. In figure, PMA plus PMB equal to 180 degree. So here write angle PMB. But here PMA plus PMA equal to 180 degree. This is given. Now this angle to angle PMA equal to dash dash. This write down here 180 degree. Therefore this angle PMA equal to 90 degree and segment PM perpendicular to segment AB. This is first. This PM perpendicular to segment AB first. But given that this point M is midpoint of segment AB. This PM is perpendicular to AB. M is midpoint of AB, means this segment PM or line passing through this, that is line PM, is perpendicular bisector of segment AB, means point P is on the perpendicular bisector of segment AB. Hence we prove that any point equidistant from end point of segment lies on perpendicular bisector of segment. Let us study about angle bisector theorem. There are also two parts. Part first, every point on the bisector of an angle is equidistant from the sides of angles. Here I drawn a figure, angle PQR. Ray QS is bisector of angle PQR. Here I take point A is taken on this ray QS, and we have to prove that this point A is equidistant from sides of angles, means from ray QP and ray QR. So given part of that theorem is here given. Ray QS is bisector of angle PQR. Point A is any point on ray QS. This segment AB perpendicular to ray QP. Segment AC is perpendicular to ray QR. And here we have to prove that this segment AB congruent to segment AC. Let us start to prove this theorem. Here in triangle AQB and in triangle AQC. In triangle AQB and triangle AQC. Segment AQ congruent to segment AQ. AQ congruent to segment AQ. Region is common side. Common side. Here angle ABQ congruent angle ACQ, each 90 degree. Angle ABQ congruent angle ACQ, region each 90 degree. Angle AQB congruent angle AQC, region given, means this ray QA is bisector of angle PQR. So here angle AQB congruent angle AQC, region is ray QA is bisector of angle PQR. Therefore, these two triangles are congruent by, this one side is common side congruent, these two angles are congruent. Therefore, these two triangles are congruent by SAA test. Therefore, triangle AQB congruent triangle AQC by SAA test. Triangles are congruent, therefore corresponding sides are also congruent, means segment AB congruent to segment AC. Therefore, segment AB congruent to segment AC, region corresponding sides of congruent triangle. Hence, we prove that every point on the bisector of an angle is equidistant from the sides of the angle. Second part of angle bisector theorem is any point equidistant from sides of an angle is on the bisector of the angle. In figure, angle PQR, point A is interior of angle PQR, and this point A is equidistant from these sides of angle. So in given part, A is point on interior of angle PQR. This segment AC perpendicular ray QR, segment AB perpendicular ray QP, and this AB equal to AC. Here we have to prove that this ray QA is bisector of angle PQR, means angle BQA congruent angle CQA. There are also two triangles are formed. First, we show that these two triangles are congruent. So, in triangle AQB and triangle AQC. Here, angle ABQ and angle ACQ both are 90 degree. Angle ABQ equal to angle ACQ equal to 90 degree. This is given. This segment AQ is the hypotenuse of both these triangles and the hypotenuse is common side. So hypotenuse AQ congruent to hypotenuse AQ, region common side. This segment AB congruent to segment AC. Region given. Therefore, in these two right angle triangle, hypotenuse, common side congruent and one pair of corresponding sides also congruent. Therefore, these two triangles are congruent by hypotenuse side test. Therefore, triangle AQB congruent triangle AQC by hypotenuse side test. Triangles are congruent, therefore corresponding angles are also congruent. Therefore, this angle BQA congruent angle CQA. Therefore, angle BQA congruent angle CQA region corresponding angles of congruent triangles. And therefore, this ray QA is bisector of angle PQR. Hence, we prove that any point equidistant from the sides of an angle is on the bisector of the angle. Observe the figure. Triangle XYZ is given. There is a property, the property of inequalities of sides and angles of a triangle. The property is a theorem. That theorem is, if two sides of a triangle are unequal, then angle opposite to greater side is greater than the angle opposite to smaller side. So, in this triangle XYZ, the side XZ is greater than side XY. This is given part. Then we have to prove that angle opposite to greater side means this angle XYZ is greater than the angle opposite to smaller side. Smaller side is XY. Its opposite angle is XZY. So here we have to prove that this angle XYZ greater than angle XZY. To prove this theorem, there is a construction. Construction is that take point P on side XZ such that this XY equal to XP and draw segment YP. Here segment YP is drawn. So to prove this theorem, observe the figure. In this figure, in triangle XYP, this XY equal to XP. Reason construction. So in triangle XYP, this XY equal to XP. Reason construction. Therefore, angle opposite to these congruent sides are also congruent. Isosceles triangle theorem. Therefore, this angle XYP equal to angle XPY. Angle XYP equal to angle XPY. Isosceles triangle theorem. This is number 1. Now, observe that this angle XPY is an exterior angle of triangle PYZ. Angle XPY is an exterior angle of triangle PYZ, and exterior angle is greater than its remote interior angle. Exterior angle theorem. Therefore, this angle XPY greater than angle PZY. Therefore, angle XPY greater than angle PZY, reason exterior angle theorem. But from 1, angle XPY equal to angle XYP. So at the place of XPY, put angle XYP is greater than angle PZY here from 1. Angle XYP. In this angle, if we add angle PYZ, then this angle XYZ is also greater than angle PZY. Means angle XYP plus angle PYZ is greater than angle PZY. Reason, suppose there are two numbers A and B, that is if two numbers A greater than B, and there is a positive number, any positive number C, means C greater than 0, then this A plus C is also greater than B by using this property. Here we add this angle PYZ to angle XYP. In figure, this angle XYP plus angle PYZ means angle XYZ. Therefore, angle XYZ greater than angle PZY. And from figure, this PZY means angle XZY. Therefore, angle XYZ greater than angle XZY. Hence, we prove that the angle, if two sides of triangles are unequal, then angle opposite to greater side is greater than angle opposite to the smaller side. There is a property of inequalities of angles of a triangle, and this property is as a theorem. The theorem is as if two angles of a triangle are unequal, then side opposite to greater angle is greater than the side opposite to smaller angle. Here in triangle ABC, this angle B is greater than angle C. This is given. And we have to prove that side opposite to this greater angle B means AC is greater than side opposite to smaller angle C. Angle C, its opposite side is AB. Therefore, to prove that this AC greater than AB. Here we prove this theorem as an activity based question. There are only three possibilities regarding the lengths of side AB and AC of triangle ABC. There are two segments AB and AC, three possibilities. First possibility is that AC less than AB. Second possibility is that this AC equal to AB. And third possibility is that this AC greater than AB. These are the three possibilities. Let us assume first possibility, that is AC less than AB. If two sides of triangle are unequal, then the angle opposite to greater side is greater. So write down here greater. Therefore, angle opposite to greater side AB is C. This C is greater than angle opposite to AC. Angle opposite to AC is B. So write down here angle B. Here angle C is greater than angle B. But here given angle C is less than angle B. C is less than angle B. Given part. And this create contradiction. And therefore our assumption, that is first assumption, that is this AC less than AB is wrong. Then second assumption is that if AC equal to AB, two sides of triangles are equal, then angle opposite to them are also equal, isosceles triangle theorem. So opposite angle of AC is angle B, opposite angle of AB is angle C. These two angles are equal. But given that this angle B is greater than angle C, given part. So write down here angle B greater than angle C. This also create a contradiction. Therefore, our second assumption, that is AC equal to AB, is wrong. And therefore, this third assumption, AC is greater than AB, is only remaining possibility, and this AC greater than AB. Here we prove that if two angles of a triangle are unequal, then side opposite to greater angle is greater than the side opposite to the smaller angle. See the adjacent figure. In this figure, there is a shop at point A. Samir is standing at point C. To reach towards the shop, he choose a way, that is C to A instead of C to B, B to A, because he knew that this distance C to A is shorter than that of C to B, B to A. Here he had realized the property of triangle. The property is that the sum of any two sides of triangle is greater than third side, and this is our next theorem. The theorem is as the sum of any two sides of a triangle is greater than the third side. Here triangle ABC is drawn. So given part is that triangle ABC is any triangle, and we have to prove that sum of any two sides of triangle means AB plus AC greater than BC, greater than third side. AB plus BC greater than AC. AC plus BC greater than AB. Sum of any two sides of triangle is greater than third side. There is a construction. The construction is that on the ray BA, take point D such that this AD equal to AC and draw segment DC. To prove this, observe the figure in triangle ADC. In triangle ADC, this segment AC equal to segment AD, congruent segment. So AC equal to AD, and reason is the construction. And by isosceles triangle theorem, the angle opposite to congruent side also congruent. So therefore angle ACD equal to angle ADC. Reason isosceles triangle theorem. At the LHS, add angle ACB, that is angle ACD plus angle ACB greater than angle ADC. From figure, this ACD plus ACB means angle BCD. So angle BCD greater than angle ADC means angle BDC. So here I write down BDC. So in triangle BDC, angle BCD greater than angle BCD greater than angle BDC. Therefore, the side opposite to greater angle is also greater. So, greater angle BCD, its opposite side is segment BD. Therefore, segment BD greater than segment BC. Here is an side opposite to greater angle is greater. But BD equal to BA plus AD. So here BA plus AD greater than BC. Since reason BD equal to BA plus AD. But this AD equal to AC. So at the place of AD, put AC. Here AD equal to AC. Therefore, this BA means AB plus AC greater than BC. Here we prove that this AB plus AC greater than BC. Similarly, we can prove that these two statements, that is, similarly, we can prove that AB plus BC greater than AC and AC plus BC greater than AB.